Hello and welcome to my channel. This is Career Tech Explorer. My name is Mark Block. I want to showcase to you today one of the key and very important activities that is carried out by data analysts and researchers alike. And that is the art of investigating a data set for normality, which is typically referred to as normality test. This is important because you need to establish the normality level of your data set in order to be able to decide on one of two things: either to decide which analytical approach you will need to use for the data, or whether to normalize data before you can carry on analyzing it. So let's jump right into R. Now this is my R environment. In my previous videos, I've already showed you how you can open a new script. If you do not know how to do that, all you need to do is to click on File, and then you select a new file and go to R script. Then you come to a new one. Then the next most important thing you need to do is to set your working directory. For me, my working directory, that's the environment within my computer that I would like all my files and all my work on this space to be saved on, is what I have highlighted for you to see. After doing that, I will need to load the relevant library. In this case, we normally use Moments. That is the library you will need to be able to carry out your normality test. After that, you will now need to call up the data. My data is saved in my computer as masters, as you can see here. So you need to call the data into R. And to call it into R, you just need to type this code, read.csv. The file is a CSV file, and then insert it in inverted commas, also inserted in bracket, and the data will come up. So if I run this code, the data would have been imported into R. So let's say we just want to view, let's say we view the data. View the data. So that is view masters. Now note that I assigned the same name of the file. I assigned the vector name masters just as it is a masters. So we move on that line of code. Data will be pulled up into your view with the grid lines, just like you have in Excel sheet or what have you. Now the columns that are of interest to us here are the pretest and post-test columns. So note the column names that we have, as well as the font type, meaning that we have it in capital letters. So in order not to waste our time, I will just paste the entire code that I've already pre-coded and tested. So let's go over it and explain it one after the other. So we need to now extract the two columns of interest that I showed you in the previous frame, and assign pretest to pretest and assign post-test to post-test. Just by way of demonstration, the main data set is masters, and then the column of interest is pretest. You enter the $sign, and then it will display to you, as you can see in this frame, it will display to you all the columns that we have within that data set. So we're interested in pretest and post-test. So you do for pretest and do for post-test, and then we are interested in two basic normality test analysis. That is Shapiro-Wilk's test for normality, and then we'll also do the skewness and kurtosis. Right, so to do Shapiro-Wilk's test, we will just assign the vector name Shapiro-Wilk test for pretest and Shapiro-Wilk post-test for post-test, and then Shapiro.test. That is the function. That is the function for doing Shapiro-Wilk test. So when you just say Shapiro-Wilk.test, and then you type the data pre-test. Okay, pre-test in there. We do the same thing for post-test. Then going down, maybe we should run each of them one after the other. We already viewed those two, so let's run this code. So that let's run this code here. Highlight it and click on run. That has been performed. Therefore, Shapiro-Wilk's test will also do the same. Highlight that and run. Then we go to the kurtosis test. We assign the vector names skewness pretest and kurtosis pretest. Skewness is a function under the moment library, and then we enter pretest and the kurtosis pretest. So when we perform that part of it, we run the analysis for that part, that will be complete. Then we'll go now to skewness. We have done, we'll go now for that of post-test. And of course, the data, the code is written in an identical form as we did for pretest, except that we're interested in the post-test columns. So run that, and then we arrive at the values. At this point, we will now begin to see we need to print. So before we print, we now assign that we type cat Shapiro-Wilk test for pretest and the number that will be given. So when you run that code now, we'll get a value printed. As you can see, the data is pretest, and the Shapiro-Wilk test W is 0.92825, and the p-value of very low p-value. So let's do the same thing for post-test, and then get the value, very low p-value. What the Shapiro-Wilk test is, as you can see. Next, we'll now type prepare a form of table that will display both the skewness and the kurtosis results for pretest and as well as post-test. Friends, if you're getting value from this video, I'd like you to click on the subscribe button and the notification bell, so that anytime I drop similar videos, you'll be the first to be notified. At any time you want to reproduce this code, it will be useful if you pause the video and then write out the code for yourself, and then you can now try it out. So when I run this, it goes ahead to print for us now the skewness value and the kurtosis value for pretest, and also for post-test. Alright, then the next thing we need to do is that most of the times we also perform a visualization inspection. That is the use of the QQ plot and the histogram plot to investigate our data. So let's first perform that of pretest, both the histogram and the let's perform both the histogram and the QQ plot. So let's first do the histogram. Now we can see from the histogram on the left side of your screen that the data, the values we have does not look like the figure we have here does not look like a bell shape. That means the data is not normal. If we go over now to do the QQ test for normality, we also see that the data is not aligned in a straight line format. Let's include a line. You can see that the data are quite outside the line. So that shows that the data is not normal. Okay, so let's perform the histogram for post-test. This is also more like we had in the case of the pre-test. So if we also run the QQ test for post-test, we can now also see that the data is not in any way aligned with the straight line record, which should, as much as possible, originate from a 0, 0 point, and that tells us that the data is not normal. So, ladies and gentlemen, this is how you carry out normality test for a data set. I'm happy that you joined this video, and I believe you are supporting value. And if that's true, I'd like you to hit the like button, share this video with your friends, and in the next one we are going to see we're going to present how this particular data set that is not normal, how we can normalize it. Thank you very much for joining. Please hit the subscribe button, and I'll see you in the next one.